Hello fellow problem solvers. So today we're going to be doing a problem from the 2010 Junior Balkan Math Olympiad, problem number 1. I suggest you try this problem out for a minimum of 15 minutes, ideally 45 to an hour and a half, but not more than 3.5 hours. If on the other hand you'd like to go along with us, I suggest you take a preliminary look for the next 10 minutes. And now, without further ado, let's begin. So this is our problem. We have A, B, C, D are real numbers which satisfy these relationships, and we must prove that their sum isn't equal to 0. So now, a common problem-solving strategy is, let's assume the contrary. And the reason we assume the contrary is like the first thing I see is if I assume A plus B plus C plus D is 0, I can actually plug stuff in. I can make, say, minus D instead of A. I can make A plus B plus C equal to minus D here. But also I want to sum these up because they sum up so nicely to 0 on one side, and on the other side I will cancel A plus B plus C plus D. So let's do that. So the first idea is like when we do that, we have ABC plus BCD plus CDA plus DAB is equal to 0. Now the question is, can we factor this in any way, shape, or form? And also, before I do this, I want to just point out that the reason I didn't just want to plug stuff in like D is equal to ABC minus 1 and then plug that in here and then get rid of, say, A by plugging the necessary thing in here and D here and here, because I think that I would get a pretty high polynomial equation to find A, B, C, D here, and that would be very difficult and complicated. And before I do that, I would like to do something simpler, which is adding these up and seeing what happens. So now, what can we do with this? Well, the first idea that comes to my mind is, okay, let me take B out. And if I take B out, I'll have AC, and I take B out here as well, AC plus CD. And then maybe I want to take something else out here. Can I get AC and CD? No, I can't. But if I get D out, I'll get plus D, I'll get AC plus dB. Okay, this is 0. I don't really see any progress with this. Maybe if I try to factor BC out, what do I get? I'll get A plus D times BC plus I need to factor out DA. DA, C plus B is equal to 0. Okay, is there anything I can do with this now? Well, I don't see anything. Now let me factor out, so let me take C out of here, and I'll have C, AB plus, what is it, BD, plus what is this? This is DA, and plus DAB is 0. Now I can factor C out with, oh, I actually know what DAB is. I know DAB is C minus 6. Or I can maybe do that, let's do C, AB plus BD plus DA, plus, what's this, C. So yeah, when I take this out, I get, C minus 6. Plus C minus 6 is 0. So it's C times AB plus BD plus DA minus 6 is equal to 0. Okay, so now I have either C 0 or this thing right here 0. And I can also do that similarly with the other things. But also, wait, if C is 0, what do I get then from up here? From C 0, I would get that D is equal to negative. If C is 0, then it implies D is negative 1, A is negative 2, and here it implies B is equal to negative 3. But then their sum isn't 0, which is a contradiction. Ta-da! So C isn't 0, so this implies that AB plus BD plus DA is equal to 6. And now similarly, we should be able to get the other things as well. And now here I invite you to play around for the next 10 to 20 minutes and see if you can push the problem further and even finish it up. Here's the next step. So what I did with this is I tried, let me see what happens when I play around with it a bit, multiply everything by C. Okay, I get this. Let me add C, and I get 7C is equal to 6. And I said, okay, well, by analogy, I should probably get something like this for A, B, B, C, and CA, just looking at which numbers appear where. And then I saw, okay, maybe this is interesting. Okay, and now what do I have? I have this. Now minus D, I add D, and I get a contradiction. And now it's a matter of me actually proving that this is actually the case, that I haven't messed anything up. So now let's do that. And what I realized is that in fact I made a mistake, so I can't really do this, because what I did beforehand was I made a mistake in factoring right here. So now we need to go back to the drawing board and get some other ideas. and like figure out if there's different things that we can do to actually solve this problem. So now the next idea for me was, okay, let me just plug in instead of d here. Like let's just plug in instead of d, we will make minus a minus b minus c. And then what we get is we get a plus b plus c times ab plus bc plus ca plus 1 is equal to 1. If you just like move things to the other side, you will get this. And now with that, I know that a plus b plus c times this. I know that this is a plus b plus c times ab plus bc plus ca plus a plus b plus c is equal to 1. And now this I know I can factor nicely, because now this is negative d, and I know that like I'm using an identity that I know from before, which is that this is equal to a plus b times b plus a plus b plus c actually plus c plus a plus abc. You can check it out that this actually works. And we have this minus d is equal to 1. And now because this thing right here, abc minus d is equal to 1, that implies that a plus b times b plus c times c plus a is equal to 0. And now this actually looks to be very, very useful. And I invite you here to pause for 5 to 10 minutes and play around with it, see if you can push the problem further. Well, by pure analogy, we should be able to get the similar thing by just exchanging c and d. We should be able to get a plus b times b plus d times c, actually d plus a, is also equal to 0. And we should be able to get like 4 of these different equations now. And the question is, what do these now imply for us? Like they're giving us something very nice. They're giving us that either a is negative b is negative c, or c is negative a. And if you look at what we know from before, we can't have a plus b is 0 and b plus c is 0, because that would imply, that would actually, if a plus b is 0 and a plus c is 0, say, then this implies b is equal to c. Actually, no, we can have this. Yeah, we can have this. I thought we couldn't have it, but there's loads of possibilities now, and we need to figure out how we're going to deal with this casework, and we do this on the next page. Now, the first thing to note here is that if, say, a plus b is 0, that implies because of this that c plus d is also 0. And then we have, I think, every single one of these cases then works out just fine. I believe, yeah, we have a plus b in this case, and in the case where there's no way there is c and d. So all of these work out. So we need to look at maybe cases. Case 1 is if a plus b is 0 and c plus d is 0. And we have a case where a plus c is 0, b plus d is 0, and we have a case where a plus d is 0 and b plus c is 0. So we have maybe these 3 cases, and we can try to solve the problem by doing this. And I invite you to check out for yourself whether you think this is a good path for the next 5 minutes. For me, this seems like a decent idea to try out, so let's do it. So let's take this case. What we have is, and what you notice when you play with this is that, wait, you get a contradiction right away. Like this is the negative of this, and here's 2, here's 3. So is there a way to get the contradictions very quick like this? And now I invite you, if you haven't seen this already, take 5 to 10 minutes and see if it is, because here's how we solve all of these cases. By a series of these contradictions, we have that -4 is 0, 3 is 0, and 5 is 0, all which give us a contradiction. And now before finishing up the problem, I would also like to show like a different way that we could have thought about the problem and come to the same or similar conclusion. And that is to look at what is missing in every one of these cases. Like here, if you, for example, like here if you multiply by d, here if you multiply by a, if you multiply everything by, what's it called now, what's supposed to be here, b, here by c, and then add them all up. Like, and not actually add them all up, but what you get is that d squared plus 1 is a squared plus 2 is equal to b squared, actually d squared plus d, a squared plus 2a, b squared plus 3b is equal to c squared plus how many? Actually, no, minus 6c. And now maybe there's something we can do to play around with this. Maybe add them all up, take into account, or maybe subtract some of them, but we could always take into account that these numbers, the sum of them is 0. And with that, this solves our problem. I'm not going to go into that. If you want to explore, go into this. And as always, Thanks for problem solving.